Hello friends and my dear students. So as in the last session we have discussed about the beam strength and the wear strength and the effective load calculation of the Bevel gear teeth. Okay, I'm just scrolling those pages so that you can recall the formulas if it is needed. Okay, either you can also refer the design data book where you can fetch up this formula. Some notations may be different, but most of the time you will get all the formula similar to these particular things. Okay, so today we will try to discuss or solve some design problems related to the Bevel gear. So let's see and start it with this example number 19.4 given in the machine design, which is design of machine element book of or machine design book of B.B. Bhandari. A pair of bevel gears with 20-degree pressure angle, means alpha is given as 20 degree, which we have written as a given data, consists of 20 teeth pinion. 20 teeth pinion means the value of ZP is given as 20. Okay, with 30 teeth gear means ZG value is 30. The module is 4N, M is 4N, 4 mm. Then the face width is 20 mm, B is 20 mm. The material for the gear is given as steel 50C4, SUT is 750. Okay, SUT is given, then you can also calculate the value of beam strength, or I will say your bending strength, not beam strength, it is bending strength, which is equals to SUT by 3 most of the time you have calculated. Then surface hardness number is given 400, VHN number you have written here as a given data. The pinion rotates at 500 RPM, means the revolution of our pinion is given 500. Then power is given as 2.5 kilowatt from the electric motor. Power is given, RPM is given, then you can calculate the value of torque. We'll see that the starting torque of the motor is 150% of the rated torque. Okay, with the help of that you can also calculate the factor. Then determine the factor of safety against the bending failure and against the pitting failure, means for separately you have to calculate for bending failure and pitting failure. So as per the derivation we have seen or calculation we have seen before, we have to calculate the value of P effective as well as we have to calculate the value of beam strength and wear strength. If we will know these two values, then we can easily calculate the value of factor of safety according to the bending failure or according to the pitting failure as it is asked in the numerical. Now let's get it started. First step, we are going to calculate it for the beam strength. Since the material is same, so pinion will be weaker. This we have discussed many times during the calculation of gears, that if the material is same for the both pinion and gears, then pinion will be weaker. So you have to design it on the basis of pinion, means if pinion will be safe, then gear will already will be safe. Now we have to calculate the value of tan gamma, which is ZP by ZG, which is equals to ZP by ZG. With the help of that you can calculate the value of gamma, pitch angle. Then we can calculate the formative number of teeth, because on the basis of that you have to calculate the Lewis form factor. Okay, and this sigma B, which is bending stress or bending stress, which is SUT by 3 as B, I have already said. Then you can calculate the sigma V value. Then ZP, which you have to calculate the value of A naught here, which is necessary for the calculation of the Bevel factor, which is 1 minus B by A naught in the beam strength formula. This is beam strength formula, in which the initial formula was MB sigma B by sigma B you have to calculate, Y you have to calculate, but this is the Bevel factor 1 minus B by A naught, which should always be multiplied in the beam strength of the spur gear to calculate the value of beam strength for Bevel gear. So A naught is dP by 2 whole square plus dG by 2 whole square. Easily you can calculate this value, and on the basis of this you can also calculate the Bevel factor, and you can calculate the value of beam strength SB. Okay, by putting the value of module is given, face width is already given, or you can also calculate it. If it is not given, if it is given, then you can directly take it as in this formula. The value of face width is given as 20 mm. If it was not given, then you can apply this particular formula, like face width can be minimum of any two factors or any two product, 10M or A naught by 3. Okay, so in this way, if you are ready with the value B, sigma B you have already calculated SUT by 3. Y is dependent on your virtual number of teeth or formative number of teeth, which you have. For that you have to calculate the value of pitch angle. Pitch angle you can calculate by ZP by ZG, and with the help of pitch angle you can calculate the value of formative number of teeth on pinion, and which is necessary for the calculation of Lewis form factor. Okay, after that you are ready with the Lewis form factor and Bevel factor, get the value of beam strength. Now you have to calculate the value of wear strength. Okay, wear strength is 0.75 B Q dP by K divided by cos gamma. Gamma is you have already calculated, this value you have already calculated, okay, which is your pitch angle, and B is already calculated. Q and K value is unknown here as of now. Q is 2ZG divided by ZG plus ZP tan gamma. With the help of this formula, you can get it this formula in your design data book and calculate this value as this. Then K is 0.16, as it is this gear is also made up of steel, so it is 0.16 BHN by 100 whole square. BHN is given, you can calculate the value of K. Then if you are able to calculate, you are having the values of Q and K in your hand, and B is already known and DP is already known to you or given in the numerical, then you can calculate the value of wear strength or SW. Okay, so now SW is calculated. Now you have to calculate the P effective. For the P effective, you should know the value of tangential load. For the tangential load, you must calculate the value of torque first. Torque is 2 pi nt is equals to the power. So with the help of that, you can calculate the value of torque, because N value or revolution per minute or revolution per second is given in the numerical. Power is given in the numerical. Then you can calculate the value of torque easily, as you can see here. Then 2 times of torque divided by pitch circle diameter, you can, with the help of that, you can calculate the value of tangential load. Now we will calculate the dynamic load first, and after calculation of dynamic load, we can calculate the value of P effective. For the dynamic load, we should calculate the pitch line velocity, which is pi dn. dP is known, revolution per RPM is also known, and C is 11,400, which is given for the steels. Okay, if it bevel gear is made up of steel, then the value of C is 11,400. V you have already calculated. The value of B, which is phase width, is given in the numerical. PT you have calculated. Put all these values in the formula. This formula you can also fetch up from the design data book, or it is given in your book. You should not remember this formula, just fetch up it from design data book in your university exam as well. Okay, keep these values in the formula and you will get the answer ready for the dynamic load or incremental dynamic load according to the Buckingham's equation. Now you have to calculate the P effective, which is equals to service factor multiplied with PT plus PD. Service factor, how you have to calculate? Service factor, as this statement is given, that starting torque of the motor is 150% of the rated torque, and as you know that service factor is nothing but the ratio of this value. Then in this way your CS value will be equals to 1.5, okay, which they have already used here. 1.5 multiplied with the PT, which you have already calculated here. The value of PT is 1193, okay, write it here, and the value of PD, which is dynamic load, which is 1653.25, write it here and add this value. Then you will get the value of factor of safety. Then according to the bending of failure, factor of safety is SB divided by P effective, and according to the pitting failure, SW divided by P effective. In this way, both the ways you can calculate the value of factor of safety, which is 1.41 according to the bending failure, 1.48 according to the pitting failure or wearing failure. Okay, in this way you can also solve the upcoming numericals or the numericals asked in your university exams. I am giving you one upcoming numerical which you can solve it by your own with the help of the calculations given or given design data, given in the numerical, and just scrolling the answers, you can go through it and match your answers after calculations. Okay, so practice it by your own and do practice with the help of design data book, because in your university exam you will have the design data book handy so that you can solve such kind of numericals in upcoming university exams. Okay, practice as much as possible with the help of design data book for these calculations of designing of gears. So we will come up with the next topic of or the last gear, which is designing of the worm gear in upcoming sessions. So do subscribe this Engineering College Banswara YouTube channel for more such updates about different branches of engineering like mechanical, electrical and civil. Thank you so much for your patience hearing. Okay, we will come up with the next topic soon. Thank you so much.